Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 30 from the Smith Organic Chemistry textbook. And this problem asks us to look at four polymers and determine the monomer or monomers from where they're made. And so for A, we need to look at the side chains that are present. So it's these groups where it's a methyl and a CO2 ethyl coming from the same carbons. And so we can safely say that those are the subunits, and so we can break the bond between the subunits, and when we do that, we see what the monomers are, and the subunits are identical, so there's really only one type of subunit here, and it's going to be this. So this is a vinyl derivative with the methyl group and the CO2 ethyl. And so when this monomer is polymerized, you get this polymer that we were given for A. So then when we look at B, we see that, again, this is only a single type of monomer, and it's joined by these amide linkages. So we can just break the carbon-nitrogen bond of the amide. And then remember that that's going to give us a starting material. And again, there's only one type of monomer here. So it's going to give us a starting material that has to have both the amine portion of the amide, and then on the other side, the carboxylic acid to which an amine will add to make the amide. So there we go. That's the monomer from which B is formed. So then we can do sort of the same thing with C. C requires a little bit more thought. So these are carbon-oxygen bonds that are holding C together. So we need to think about what type of monomer subunit could be polymerized to make something like this. And the key is the carbon-oxygen bond. And so earlier in the chapter, we saw the anomeric polymerization, or pardon me, the anionic polymerization of epoxides. And so that's what's going to be going on here. So we draw the epoxide. We see that there are these CCH3 side chains on each of these monomers. And so we can just go ahead, add that in here. And again, that's the only monomer here. And so that's how D is different. So D requires sort of a good bit of thinking about to see how something like this could be made. And really the only way is to break both of these bonds in each subunit. And so when you do that, you get the linker pieces are going to be these. And then you're also going to have these diols. And so each of the alcohols in the diol is going to displace a chlorine here. And so that's how you end up getting this alternating pattern of diol and then carbonate and then diol and carbonate. And so that's really the only way to make D. And so that's the answer to Chapter 31, problem number 30.